Okay, everything looks good. Microphone seems to be working. Hello, hello, hello to anyone watching in the future. I hope you're having a fantastic day. If you've been watching any of my previous streams, you may have noticed that I'm getting kind of obsessed with SDFs, or signed distance fields, also known as signed distance functions. And I think that they could be really cool for a horror game, which is what I want to work on. First, as we all know, horror games make the most money. Well, not the most money in terms of volume, but they are the most successful genre of indie games, or of games in general. They're extremely popular, and the cool thing about them from a business perspective is people don't want to play the same horror game over and over again. They want to play new horror games all the time. So people who play horror games buy lots of horror games, which is great for indie developers. But actually, just from a tech point of view, I think that if you have a look at this video here on the screen, SDFs could be really interesting for the horror genre. Like, imagine you can warp and manipulate to like the environment like this in real time. You've got this thing like following you through the ground, perhaps. You get a lot of interesting lighting effects and lighting shadows and smoke and stuff like that, mist and fog. So yeah, very cool stuff. So I just think it would be an interesting exploration. Now, today, I'll show you a little example of what's going on. So yesterday we did this chunk generation of voxels. And today, we're going to take this really unoptimized Raymarching of these voxels. So these voxels are all cubes, and we've sort of smoothly meshed them together. And I've made a little viewport that's only a third of the size of the screen, because otherwise it can't run at more than like 10 FPS on my computer, which is crazy if you think about it. So what I'm going to try to do today is optimize this so that we can get it running at a smooth frame rate, but we'll see if I can actually do that, because I've never done anything like this before. But I got some rough ideas, and I spoke to a friend who also gave me some ideas. So we'll see how that goes. Now, let's see if I can draw a little example here of what the plan is. So, actually, I've already done that. I think I did it yesterday. But I will go over what this means. So the basic idea is, actually this is going to be a little bit incorrect, I think, to how I want to do it. So you can say, imagine this is a 3D cube here of voxels. And what we want to do is let's say we're standing at the bottom. So we're standing below this, we're looking up. Let me just draw a little eye here. So we're standing down here, we're looking up that way. And the way that we're currently doing our Raymarching is we're basically checking every single object in the scene, which is a lot of cubes, and whether our particular pixel, so for every single pixel on the screen, whether that pixel is hitting, or rather what the closest shape is to that pixel. And so we're evaluating every single shape for every single pixel. But what we could do, so that's called sphere casting. And what we could do, I think, I'm not sure because I've never done this before, is we could, when we generate our chunk, we can also generate a signed distance field that's at a scale of a voxel. So for example, I'll show you what that means. Actually, I should probably explain what a signed distance field is just in case you don't know. let's say that we have, actually I can use this. So we've got these solid shapes here, right? These are all inside a sign distance field. And usually the way it would work is, actually I'll use a 1D example first. So we use one dimension here. We'll say this is a line in one dimension. And we've got these points, and let's say these are 1 unit. So we can just say 1 meter or 1 centimeter, however you want to think about it. I'm just going to say 1 meter, because that's what it sort of ends up being in in my engine. At least that's what I assume it is. So 1 unit is 1 meter. And we can say, even though this is 1D, we can say the point between these two is actually solid. So I'm just going to draw a little line here. Can I zoom in? There we go. There we go. Right, so this is a solid point, and everything outside of that is air. Actually, I'll make these two both solid. Actually, these three can be solid. Okay, so then the values we would assign to these intervals would be the sign distance field. So we'll say usually 0 is going to be on the edge. So this is the distance to the closest solid object, or to the object that we're evaluating. And then inside, we've got like -1 and -1. So right in the middle here, it's going to be -1.5. That's why it's a signed distance field, because we can go to the negatives. Okay, and then outside, we just say 1, 2, 3, 4, 5. So if we're standing over here at 5 in this one-dimensional version of the world, and we say, okay, what's the closest shape from my position, we're going to get, oh, it's 5 units somewhere. But actually, let me say we're not standing at 5. Let's say we're standing at 3. Okay, we're standing here. I'll draw a little person. And we want to ask the sign distance field, or the sign distance function, you know, how far away am I from an object? And it says 3. Now, we don't know which direction it is, so we might say, oh, okay, we're 3. Okay, we're going to walk 1, 2, 3. Okay, there's nothing there. Right? That's a bit of a problem, because we could check either direction in this case. And of course, that problem expands to the third dimension, or the second dimension, and the third dimension. Right? So we have to check first, you know, this direction and also this direction to see which one is closer. So we say, sorry, I'm explaining that incorrectly. But essentially, it just tells us how far away we are, not which direction we should check. And so we can use this, I think, in our 3D version to say the same thing, but in 3D. So basically, we've got these voxels here that are solid. But rather than having 0 be this threshold here, I'm going to say 0 is actually this whole voxel here. So this whole voxel is 0. This one is 1, this one is 2, and this one is 3. And the cool thing about this is we can say, okay, if we're standing down here, well, let's just say this extends down, and we've got a number 4 here. And we're standing here, and this is 5. And we want to say, okay, I'm looking in this direction. How far can I move before I hit a voxel? And if this number is 5, because there's nothing over in these spaces, nothing over here, there's nothing over that way, there's nothing over this way, we know the closest one is here, but of course we don't actually know the direction. So what we're going to do is we're going to make a big sphere from our point of view. That's why it's called sphere casting, and it's going to be 5 units in radius. And we're going to say, okay, well then that means we can move to here. So we can move 1, 2, 3, 4, 5. We've moved up to here, to this 0. That was actually a bad explanation. We didn't need the sphere because we've already got the numbers here. But essentially, we know we can move 5 units. So we move 5 units, and now we're inside this 0. And if we're inside a 0 voxel, we do a different kind of Raymarching where we, I think what we can do is we can grab the voxels in like 27 voxels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, 27. We can grab the small chunk of voxels here. So I'm just going to draw that real quick. Oops. There we go. Can I rotate these? I never tried to do this before. I don't think that's going to work. No. Of course it's not going to work. What am I doing? Maybe it would work with a skew. But anyway. So we've got these voxels, which is actually this many. Sorry, they're really unevenly drawn. Hopefully the point can come across though. That's horrible. I should have just done it with a pen. So I've got the voxels here. Right? Okay. So we're going to grab this little cube once we get to this point, and we're going to just test all of these. And we're going to say what's the closest one and to our ray and the direction and stuff like that. And that way we should be able to get a saving of only checking once we hit one of these 0 points. So right now what we're doing is for every single ray, which means every single pixel in the screen, we're checking in this little box here, we're checking every single one of the cubes. So even the cubes at the top left corner of the screen, the white ones that this little box can't even see, we're checking those. We're checking the ones at the bottom, we're checking the ones off the screen, right? Even though they're off the screen, we're still checking them. So we don't want to do that. So what we want to do is fire the ray out until we get to a point, which is inside one of those 0 voxels, and then do the basic, the same thing, the check, but only the surrounding voxels. So I've never done anything like this, so this is all just theory. Okay, encoding overloaded, turn down video settings, or use a faster. Alright, so when I run that game, it seems like the encoding gets messed up here, which is not great. Twitch enhanced broadcasting is controlling some of your stream settings. Alright. Interesting. Right, so it's all automated, but I'm getting encoding errors. Well, maybe I'll have to manually do it. We'll see how it goes. So yeah, this is all just theory. I haven't done this. It's all just like an idea in my head. I think it's going to work though. I have no idea how to implement it either. But the first thing we need to do is generate that distance field, which I think we can do in a compute shader. I'm lagging. You know what it could be? Thanks for telling me, Ethan. I think yeah, I have a feeling that working on Raymarching on a stream is going to be potentially bad. Because if I make a mistake and it's really laggy, well, the stream is going to be really laggy. Because my computer is dying. But it's better now? Yeah, thanks. Thanks for letting me know. Okay. Yeah, so it was the expensive operations I was talking about. So we're going to try just generate this density field first, which should be kind of Maybe I shouldn't say it's going to be easy, because that's like, you know, jinxing it or whatever. I think it'll be not too difficult. If we look at, where is it? There's a 3D image here. So this is our terrain that we made. Let me just zoom in. It's flipped, by the way, so it's sort of got this overhang shape, and then if we look in the game, the overhang is, you know, this way. Yeah, so it's actually upside down, but it doesn't really matter. So here's our terrain, right? And we've just got red and black at the moment. So red means solid, black means empty. But if instead we change this to be, you know, the distance from the solid pixels, so it could be 0, then 1, then 2, then 3, then we could get the result that we want. However, well, these are all floats right now, which is not what we want to look at. We want to look at the integers. So we've got a lot of random numbers in here. Oh, int is not the right size. We need a U8 or something. Is a U8 a type? No. Is it called, maybe char will do? Yeah, that'll do. So we've got -1. Okay, I want to do unsigned char. Actually, no. That's correct. So all these -1s are currently the solid pixels, or solid voxels, because their value is 255. And what we want is all the solid ones to be, I guess 255 is fine. We can leave that the same. But all these other ones need to be a distance, and I want the distance to start at 0. It doesn't really matter, really. So I'm gonna make a compute shader to do this. I'll call it fill chunk SDF or something like that. Call GLSL comp.glsl. So we're going to need the texture that we're sampling. So we can actually just grab that from here. Going to need one of these. We're not going to need any camera position. We are going to need to write to it though. Can we write to a sampler? I don't know about that. Do I need to convert the texture into an array of data and then put it in a buffer and then update the buffer? Let's have a look. Vulkan write to texture in compute. I'm pretty sure we can write pixels to a texture. Let's see what Reddit has to say. You need to synchronize accesses using memory barriers. That's okay. Synchronization examples. Well, let me read the question first. I've written a small path tracer in OpenGL. I'm thinking of porting it to Vulkan. My primary target is, of course, the new Vulkan ray tracing extensions. But it's always good to have compute shader fallback. This is how the OpenGL shader works. You read the previous frame's contents, blend it with the new color, then store it back. Now my question is, does this work in Vulkan? Considering you have to synchronize everything explicitly, do I need to synchronize the compute shader accesses in the shader as well? Should I store a different texture and blend it together? Okay, this is not really the kind of problem that I have. What I want to know is Vulkan write to texture. in the shader. Someone else is also porting their ray tracing engine from OpenGL to Vulkan. This is not really what I'm talking about. How to render. Let me just look at this Vulkan guide. I mean, I know we can use a fragment shader to render to a texture, but that's not what we want to do. We want to use a compute shader. Actually, I've got another compute shader that I for the marching cubes. Marching cubes. Yeah, I think it's right, so we've got a read-only buffer and a write-only buffer. I guess we can just do that. And we do need this actually. This line here. And we're going to do 16 by 16 by 16, I guess. So we'll use one core for each voxel. I think that would be fine. That's the local size. Do we want to do that, or do we want to do dispatch? Okay, let me have a look at this. Local invocation ID, global position. Yeah, we don't need to worry about the global position. So basically we want to take some 3D data I guess I'll just put it into a buffer because I'm gonna have to anyway. If I look at I've got a function down here called copy data to image, which takes in a staging buffer and then copies it, or rather a pointer to the data, uses the staging buffer to copy it into a texture. Anyway, so yeah, I guess I will just write it to a buffer. That should work. And it's like this, write only buffer, something like this. So actually I do want std 430, and this is going to be a unsigned character buffer, signed distance field. So let's see, hang on, we need to get the position that we're at now. So this is going to be the local invocation ID dot x, y, and z. I suppose we can just use that directly. We don't need this. Check. GL local invocation ID. So this is going to be our coordinates. Not sure if that's going to be a float. Can I convert it? Maybe? So I got it. The way I'm going to do this is really naive. I'm just going to literally check every voxel and find the minimum. So we're going to say dist equals, although I guess, should I use floating point numbers for this? Because there's going to be diagonals, right? I just did a straight example, but on a diagonal here, you would have like a 0, and then I think a 0 here, and then a 1, 1, 1, 1, 1, and then a 2, like this. Yeah, that could be fine. So basically, even on a corner, I would just make it a 0. Which means the distance between this and this we're always doing the center points, right? So the center point between two cubes, whoops, on the diagonal. We'll use a float, and then I will round it down, and we'll just see how this goes first. Dist is going to be, I guess, min dist, and we'll just make that a big number. Or actually, it could just be 16. No. 16 squared plus 16 squared. Square root of 16 squared plus 16 squared. Or cubed. Whatever. We'll just make it a large number. It should be fine. Now, let's see. Coordinates. Okay, so I've got the coordinates. We're going to have to loop over every axis. So I want to do it the really naive way first, and we'll just see if it works. So that'll just be literally iterating over all three axes. Like this, and then checking the distance to coordinates. So if length of, actually there's a distance function, distance coordinates to these coordinates. And we also need to check if it's solid as well. I didn't do that part. So we need to look up this texture. How do I do that? I think it's just texture, and then world text, and then position is going to be x, y, z divided by 16. That's the size. Wrong language, I can't do that. It's going to be a pixel value, so it's dot r. It's a float. V, if v is greater than, yeah, this should be fine. If v is greater than 0, then check the distance. There's a lot of loops and ifs in here, which is going to make it slow, but it's just testing to see if we can get it working. Distance is what? We can actually say min dist equals min dist, and then this distance. No if statement. But there's an if statement inside the min function, so same deal. Okay, return. Wait, return? I'm not returning something. Then we've got to say for this particular voxel, in our SDF buffer that we're going to write to, I'm going to write out floating point numbers first, just to make it a bit easier to visualize. So we'll just say SDF chords. Wait, how do I get the index into this? It's going to be x times 16 plus y times 16 plus z. Is that right? Or is it times 16 times... I'm not sure. And then we do min dist. Okay. So it's probably not going to compile, but let's have a look. I've got to edit the build file. What's it called again? Fill chunk SDF. Okay. Okay. Alright, there's a lot of problems here. Yeah. I'm trying to update something that might be updated by other threads. That's fair enough. Okay, can I get an error message? Compute shaders require ES profile with 310 or above, or non-ES profile with version 420 or above. Oh, did I not put a version? No. Okay. Scalar integer expression required on line 27. Oh yeah, these are not integers. That's fair. Okay, compiled. That doesn't mean it's going to work though. So let's go to main, and where do we generate the SDF? 3D texture. So I've got that function, copy data to image. I must have used it somewhere. Here it is. Alright, and now I can call what? Compute dispatch? No? It's going to be a command. Dispatch. Is it just dispatch? Yeah. Command buffer. So we do want to do 888 here, I think, and then in the not 8, 16. I think in here we want to do 1, but then the local invocation ID is going to be wrong. So we need to use the... Actually, you know what? Let's just leave it for now, and I'll just do 111. It's going to be really slow, I think. And we also need... No, nothing. That's fine. Okay, so we need to load the shader somewhere. We need to make a pipeline for it, I guess. Graphics pipeline. Oh, okay. So is a compute pipeline? Yeah. All right. So we need to make a compute pipeline as well. All right, this is going to be a whole thing, huh? That's fine. Compute pipeline. Create info. Stage is compute. Layout. No. Apparently. What is layout? Pipeline flags. Pipeline layout. It's a... Okay, we need to make one. Oh yeah, that's right. That's normal. So usually we make the layout first. Compute pipeline layout create. Is that right? Or is it just pipeline layout? Okay, set layout count, push constants. Do we need push constants? No. I guess we'll have one set of descript. Wait, do we need just? Yeah, we do. What is this type again? Descriptor set layout. What's the problem? Okay, doesn't like that. That's fine. Okay, vk.descriptor set layout. Really? I gotta, wait, what? Okay, I gotta look at my pipeline creation code. Where is it? Ah, you make the bindings. Then you make the layout. Okay, gotcha. I'll just copy this. Where is it? Okay. We don't want anything in the fragment shader, it's all compute. So binding 0 is... we don't actually have anything on binding 0. Let's put this on binding 0 and this on binding 1. Binding 0 is the texture. Binding 1 is the write-only buffer. Storage buffer. Okay. Good. And this is going to be... that's all good, actually. That's a strange error. Oh, pipeline shader stage create info. Let me have a look at my create pipeline function. It's down here somewhere. Where is it? Here. So it's only set up to create graphics pipelines, I think. That's fine. Alright, so need one of these, which means we need one of these. Pipeline shader stage create info, which looks like this. Okay. Oh yeah, right. This is where you provide the source code. Okay. Stage is compute module. So we need to actually make this as well. What is the type? The type is shader module. So this is something we need to make. And we need the device, that's fine. Device, the shader module create info is what we're going to put in right here. Shader module create info. No allocator, callback, and I'll just make a variable to put it in here. Okay, and here's the stuff we need. Shader module create info. Code size is, what have I used in the other ones? I think I just load it, right? Load like this. I can't get access to this variable here. That should be fine. That's not fine apparently. Entry point. Wait, is this the wrong? P code, code size. This is the wrong thing. The hell is that? Okay, that's better. I'm gonna have to set up the pipeline function to handle compute shaders soon. Not right now though. Comp, build chunk SCF, yeah. Okay. Apparently that's not valid, but it got built, didn't it? Yes. File, oh, full, yeah, fill. Thank you. That's all good, I think. What's the P name? Is it, that's main? Yeah, we need the pipeline layout, which I didn't make yet. Where is it? So it usually looks something like this. Okay. So what do we got? Pipeline layout, create info. We've got some push constants here, which we're not using right now. Set layout count is for the descriptor sets, which I believe are right here. Descriptor layouts. We're actually just using one. Why are we using multiple down there? Let's have a look. Right. Well, I've got the option to use multiple, but I only ever use one, it looks like. So I'm just going to say pointer to descriptor layout, descriptor set layout. and it's going to be one of them. That's fine. I think that's it. I don't think we need this base pipeline index or base pipeline handle. Flags, I don't think we need anything of these. Okay, so the pipeline exists. Now we need to make the command buffer. Single time commands, I guess we can use this, right? This returns a command buffer, single time commands begin, okay, context, single time commands end, okay, context, and command buffer. And I think I have to bind something, right? Bind pipeline, perhaps? Pipeline bind point. What do I usually use? Oh, right. Compute, and it's going to be the compute pipeline, which is apparently not a thing. Oh, because that's actually just the create info. Whoops. I could do create pipeline. Is that what it's called? Create graphics pipelines, create compute pipelines. Context, pipeline cache. Wait a second. Okay, I can apparently just put an empty object in there. One, create infos. That's going to be what we're going to use right here. My brain is still not working very well. I actually feel worse than yesterday. Which is kind of lame. Pipeline, this is going to be a, is it compute pipeline? No. It's just a pipeline, isn't it? Okay. This may work. Of course, how am I going to test it? I guess I can't test it in RenderDoc because it doesn't happen in a render pass. I think. Hey Derek, how you doing? Voxel game engine? Yeah. So that was interesting. We got a crash, which is good. Let's see what happened. Okay, I guess it timed out. Is there an error message from Vulkan? I can't use 16 by 16 by 16 local size because that's too many for my GPU. That's fine. We'll just do 1 right now. That should be okay. Okay. Alright, well, it probably worked. I mean, it probably ran, but I need to be able to see the result, so let's see, there's some errors here, that's good. So we attempt to implicitly reset the command buffer that does not have The command pool create reset command buffer bit set. If the command buffer was allocated from the command pool, command buffer must be in the initial state. Okay. So this particular pipeline created with this layout statically uses descriptor set 0, which is not compatible with the currently bound descriptor set's pipeline layout, because there's no pipeline layout bound. Okay, let's have a look. Yeah, that's fair. I need to bind the descriptor set compute, and it's going to be just this pipeline here. Actually, what is it called? The layout is just called layout. Okay, that'll do. And the descriptor set is called... Is it descriptor set layout? What's the type of this? It's descriptor set. Which is neither of these. I think I need to... I'm missing a step. I need to do this part here, allocate the descriptor sets and update them. So this would be, let's say down here. Okay, that's fine. Let's have a look. So we got this descriptor pool. Yeah, we can just use that, I think. Is it called? No, it's not called that. What is my descriptor set layout called? It's called descriptor set layout. Okay. That should work then. This we want to put here, descriptor set, and it's going to be a descriptor set. So we don't have a uniform buffer, we've got a storage buffer. Let's have a look at the shader again. Storage buffer is binding 0, binding 1 rather. So this is binding 1, and we didn't actually make the buffer, so we need to do that. So I'm just going to make all this stuff locally in here, and then I'll fix it up later. And this is binding 0, and it is actually the same thing. So we're going to say descriptor set. That's fine. The sampler. I mean, I guess we can use the same sampler, right? I'm not sure. I think so. Alright, so we need to make the storage buffer as well. So let's go to where we did that. I think I made a function for this. Yeah, that's great. So I want to make a function. VK, I think it's called buffer create. So create image should be image create, not create image. Just to make it consistent. So it takes all of these things, that's fine. Pointer to the context, usage flags is going to be storage buffer. Size is, what did we decide on? A bunch of floats. 16 by 16 by 16 times size of F32, and I just realized we already have a variable for this called chunk total. And we have to wrap this in a device size, I believe. Now we've got property flags for the memory. We're going to use host coherent, host visible, because we want to look at them on the CPU. Sharing mode is exclusive, and we get back a buffer and some memory, so that's good. So storage buffer, memory. So it's a handle and the actual memory. The size, I guess I'll actually make that a variable, sure. Okay. But the memory is not bound, or is it bound in this function already? It is. Okay, good. Okay, let's see if this works. Hello. There we go. Okay. Where are the errors? There is an error still, which is begin command buffer attempts to implicitly reset the command buffer created from the pool. It does not have the reset command buffer bit set. Okay, I got to do something about that. Should I add a semaphore? I mean, this should handle it, right? Q wait idle. It's equivalent to having submitted a valid fence to every previously executed queue submission command that accepts a fence, and then waiting for all of those fences to signal using wait for fences with an infinite timeout. Yeah, so it's just like a really quick and dirty synchronization thing that should be working. So this error is about reusing command buffers, so I need to look at that. I'll just copy this and have a look. Okay, we'll look at Stack Overflow. Oh. Okay, we can do something like reset a pool. So let's see, can we do that? Reset command buffer. And the flags release resources. I don't know if I want to do that. Will that work? Let's see. Oh, that didn't build. Okay, apparently that's not allowed either. Command buffer must have been allocated. Okay, so I need to look at the pool creation. So create command pool. There's another one. Here it is. Flags. Reset command buffer. What does that actually do? Right. Okay, so I could be in a race condition if I'm not careful here. I believe. Okay, that didn't work apparently. Or did I not compile it? I didn't compile it. Okay, so that works, but what did I actually do? So we're encoding stuff into a command buffer, which gets submitted to a queue. Yeah, I understand that. What about the reset? The command pool you can allocate as many as you want from the pool, but you can only record commands from one thread at a time. Right, okay, that's fine. Once a command buffer has been submitted, it is still alive and being consumed by the GPU. And at this point, it is not safe to reset the command buffer yet. You need to make sure that the GPU has finished executing all the commands from that command buffer until... Oh, okay, I see what's happening. I didn't wait. I think I can actually delete that. And this. And add... Well, actually, this does wait. Wait for what? Wait for compute shader to finish. How do I do that in Vulkan? Use a semaphore where you signal the semaphore. So, okay. You need to add a pipeline barrier. You can find some sample code if you Google pipeline barrier. Right. How can you wait for the compute shader is finished in Vulkan? No one answered that question. Do people just not use this API or what? Or is it just a dumb question? Not a fence, right? I mean, it could be a fence, because you do... Yeah, it's a fence. Why are they talking about semaphores? You would use a fence in OpenGL. Semaphores for GPU to GPU synchronization, isn't it? That's kind of what I thought. Maybe I'm wrong. A simple Vulkan compute example. Okay. This is not looking very simple to me. I mean, there's a bunch of C++ stuff in there. It's already too complicated, you know? Like, what is this? Is this CMake? Crazy. Okay. Goes through all the initialization steps, so I'll just scroll down a bit. Creating the compute pipeline. Okay, cool. Creating the descriptor set. Okay. Submitting the work to the GPU, recording the commands. Alright. Now, the command buffer recorded, we can finally submit the work to the GPU. We create a fence. Okay, that's... So you get the queue, create the fence, submit. See, I don't understand any of this because it's all wrapped in... Like, what is this? Submit info, submit info? Is it making a submit info? I guess so. And then we submit a fence. And the fence was created with create fence, which was created with create fence, fence create info. Okay. And then we wait for the fence. But how do we know what the fence is waiting for? Maybe it's just... Maybe Vulkan just knows if you dispatch something and then you wait, then it's obvious what you're waiting for. Let's see. Vulkan fence create info. So no flags. Signaled. Okay, yeah, no flags, we don't have to do anything. That's fine. No allocator return info, and we get a fence back. Alright, so we'll make the fence up here. Okay. And what was the next thing we need to do? Submit info. Oh, that's for the command buffer. Wait for fences. Alright, so if I understand correctly, I can do wait for fences. But see, why I'm confused is because I was already doing the queue wait idle thing, which should have worked, I think. Timeout, use64 -1. Can't do that. Suggestion. Right. Let's see. Yeah, okay. So the command buffer was still not reset. Do I have to make a new command buffer every time? I don't think so. You put it back in the pool, right? That's the whole point. Oh, did I not? No, I did finish with it. It's finished here. Maybe I should wait. Oh, I see the problem. Maybe I should wait here. No. Also, it's just waiting forever because I don't think it understands what the fence is for. That's why the screen is just black, right? I think. Let's see. Yeah. Weird. Queue wait idle. Well, I already do this, so honestly not sure. Reset command pool. Oh, so you are supposed to do that. Okay. I'll do it manually. I don't think I need this fence. If I reset the command pool, context dot device, the command pool is where is it? It's called staging. Is it the command? Is it just command pool? I don't know. That's what everything's using, so I don't think we should do that. Yeah, it's still going to complain because I didn't add the flag. Alright, I'm just going to add the flag for now, and I'll cover this. I'll look at this another time. Too much time has been wasted on this. Oh no, it is just one command pool that I'm using, which is not for everything else. I mean, it's just for my one-time functions here. So, where is it? Create arbitrary command buffer. But where do we make the command pool? Not that one. This one, yeah, there we go. Alright. I shall do that. No errors, but that doesn't mean there's no errors. It just means there's no errors that the validation layer caught. Anyway. Finally, we can maybe look at a frame, but not going to be able to see the buffers, because I probably need to bind the buffer to another shader to look at it. Yeah. So the frame, it doesn't happen in the frame time. I could try to do it every frame. This is what I did before, actually. And when I was working with compute shader, I just put it in the frame, in the main loop. And it was really slow, but I could see it in RenderDoc. I guess I could try that. So basically I want to grab this. And put it in here. So now we're going to be running the compute shader every single frame. It's probably going to be really slow. Yeah, so actually it crashed. Nice. All right. Oh, because I'm allocating descriptor sets every frame. That's probably not a good idea, huh? Creating the whole pipeline and everything. That's not good. All right, I'm not going to do this. I'll do the other thing that I was thinking about doing, which was I will have in my SDF shader, I'll just bind another buffer and look at it. So binding equals 2, and we'll call it a, it's not called storage, it's called buffer. Sure, read only, and this is just whatever. It's going to be a buffer of floating point numbers. I think. Did we do floats? Yeah, we did. And it's going to be 4,096 of them. All right. And we just got to add that to the descriptors here, so that's fine. We need this one as well. I'm going to copy this. So it's a buffer. Storage buffer. Binding 2, and we don't actually have the buffer stored in the context, so I guess I'll have to do that. I'll call it SDF storage buffer. And then down here, and I guess I'll add size as well. Okay, so SDF storage buffer, size and memory. Okay. I think that's everything. I probably missed one spot, but let's see. Yeah, what is it? Buffer handle is null. Okay. Because I'm making this pipeline last, I can't do that. I need to make it before the other ones. That makes sense. Or at least I need to make the... Yeah, I'll just make it before the other ones. That's okay. I think... Wait, but I'm using this cube voxel sampler. God damn it. I need to make the storage buffer. There's just a lot of typing to do with Vulkan. VK storage. Context rather. Okay, now these are going to not work because they need to be vk context dot stf underscore storage buffer. Same thing here, and get rid of those. Except, I guess the buffer's not pound. We have to bind the buffer, don't we? No, we don't have to bind storage buffers apparently. Yeah, okay, that's fine. No errors, and everything looks okay. So, if that's the case, hopefully we can see the storage buffer in the fragment shader here. I think it's this one, right? Wait, is it the right pass, or is it this pass? This one is the sampler 3D image. No, not this one. Yeah, it's this one, but it's not showing up here, probably because we didn't use it. So it got optimized out or something. Let's have a look. Okay, so I got this test binding number 2. I'm gonna grab a number from here and do something with it. STF underscore. Wait, what was it called? Damn it. Numbers. 0. So I'll just grab the first one, which shouldn't make a difference at all. All right. Now, hopefully, I can see the buffer in here. Let's see, pipeline state, here it is. All right, excellent, that totally failed. So we've got, oh no, it didn't. We've got a 1 here, because we only called it once. So I guess that's a success in writing the data, but if we call this 16, 16, 16, and then we need to go into the compute shader, change this coordinate to, it's global Vulkan compute shader. What are these called? Group index. Okay, GL workgroup ID. All right, so this is probably a bad way to do it, but let's see if this works. Whoops, I need to run it in RenderDoc. Okay, and we got the buffer, and it has 1 number. Wait, no, it's got more than 1. There's a lot of zeros, which is not great. Does that mean they're solid? One, that looks like a very valid number. That looks like a diagonal to another voxel. The thing I'm a bit confused about is all of the empty space. Because if we look at the 3D image, can I look at this somewhere, please? Texture viewer? No. Where was it? It's used in here somewhere, right? Am I crazy? Is it this one? Here it is. Hang on, how did I get to that view from before? Pipeline state, and then I click this button. Yeah, there we go. Now there is a lot of empty space. That is true, but even on the other slices, it's definitely less than half overall, I think. Maybe about half. So this should be about half full, but it looks like almost all full. I mean, almost all empty, which is not ideal. So I think that means this workgroup ID is not correct. Or actually, it could be my indexing. Could be my indexing. I'll be right back. Gotta go to the bathroom. All right. Let's do this. How to index into linear array using 3D coordinates. Depends which direction you want to start from, right? Okay. Hmm. Okay, that's interesting. Um, I don't understand why he uses max x and max... Oh, because they don't know the bounds? Oh, because you need the bounds. So this is just like the width, right? And that's the height. So A is 1. 1 times x. Okay, so you move along the x-axis, right? Plus b times y. So that's the max x. So 16, let's say in our case. I'm not going to do the plus 1. That's just going to be 16 times the amount of rows up you want to go, plus c, which is the whole area of a flat face, in our case, times z, plus d, which is 0 always. Okay. I'll just write a function here. Int index from coords, and I will take a ivec3 and I'll say return ivec3. Oh, sorry, return coords dot x times, no, just coords dot x plus coords dot y times, I need the width and the height, 16, plus coords plus z times 16 times 16. That should be right, I think. Can you just convert an ivec3 like that? Apparently, yes. Oh, I need to run this in RenderDoc. Launch, and there we go. That looks much better. Yep. Okay. That looks much more like what I was expecting. Cool. I did notice that none of the numbers are negative, which is interesting. Some of them are exactly 1, which means, and a lot of them are 0, and if the distance is going to be 0, that's going to be a bit of a weird problem, right? If v is great, oh, I only did it, okay, that's fine. So I'm only checking the solid points. Actually, I want the opposite. If z is 0, can I just convert this to an integer perhaps to get an exact comparison here? Whoops, keep running it in the wrong program. Okay, here we are again, and here we are in the buffer. Alright, so they're all 0s, and all the empty space should be down here. Yeah, that's looking good. That's looking good. So, I can tell just at a glance some of these empty spots are, you know, just surrounded by, are like right next to other voxels. Some of them, this one's a diagonal, 1.41, on the same level, or it could be like diagonally up or diagonally down. That's good. I think these numbers look pretty good. So, what this gives us, essentially, is the distance we can travel through space before hitting anything. And I think if we have a look at the Raymarching fragment shader here, this would basically replace this value here. So we would increment the t by the number of the starting point, and then we'd get straight to next to geometry. So if we're inside a cube, a voxel cube, like a chunk, like we are at the start here. So we're inside this chunk, right? If I look up, we're totally inside of it. And so we already have a value from the point that we're looking at, which would be one of these values. And that would tell us, okay, we can move this far until we hit a cube. And so it's not going to work. I think it's going to have a bit of a problem, but we'll see if we can get this to work. So what I need to do now is basically grab this buffer, put these numbers into the 3D texture. The 3D texture looks like this. Can I look at the contents? There we go. So instead of zeros, it's going to have, well, it'll have zeros here. That's the idea. 0, 0, 0, 0, 0, 0. So I'm going to, I think I can just do a simple -1 and then floor it. And just add those numbers in here. We'll see if that works. But basically, I'm going to change this from a float to a character, which is an 8-bit. I don't know if there's precise types in not STL, GLSL, so not sure. But we'll do min-dist. I'm going to do -1, and I'm going to floor it. I think that will give me the result that I want. Now I've got to go over to the other fragment shader here, because this is going to be not floats, but characters. I suppose actually I could just read this buffer. I don't have to put it in the texture right now. We get it working by using the buffer. Line 20, there's a problem because what? Is it not a type? Yeah, I guess it's not a type. GLSL types in Vulkan. Okay. So we've got int, uint, etc. Huh. Oh, that's kind of a problem. So if I want 8-bit numbers, then I've got to use textures or pack them manually. Is that what I'm getting here? That's kind of annoying. Like, why would byte not be a type that you can use? They all have exactly 32 bits numbers. There's no smaller ones. Okay. Let's see. Since I don't have much time, I'm going to try and do something a little bit quick and dirty here. I will just still do this, but I'll just leave them as floats. And we'll see if we can use that in the Raymarch. Let me have a look here. Where is it? 176, 175, view contents. No, not the image. I want this buffer. Okay, bunch of negative ones. That means they're inside something, I think. And then 0 means they're right next to something, right adjacent to something. Okay, this could be useful. Let's see. So if we go to the Raymarch and we go here, we're going to sample from... I can just sample right here. I can say ray origin plus equals ray direction times SDF underscore, what's it called, values? I keep forgetting what I called it. It's really annoying me. It's called numbers, isn't it? Numbers. And then we've got to get the index, which is going to be... Wait, how are we going to get the index? We've got to find out where we are in the world, which is the camera position, X, Y, Z. Okay. So I get this. And I say index from coordinates, IVEC3, ray origin. So we're already starting the ray origin much closer, assuming this works. Well, it still seems to do the ray marching. That's a good sign. Let me just turn it back on for more of the cubes. And I will actually tone it down a bit because it was making the stream lag. So we'll just do a 4x4. What? Does that not build? Oh. I still need to do this apparently. For D equals... I think I can do that. Okay, now... I don't have any really good way to test the speed of this right now, so I might just make the stream lag. I'll do 8 by 8 first, 8 by 8 by 8. Yep, encoding is getting messed up. My CPU is dying. Let me try this again. So I got it open in, you know, that's weird. So I was watching it in the task manager and my CPU was on like, for this program was on like 0%. And then the GPU was on like 0%. Or maybe it was the RAD debugger. Maybe it was, let me check. Oh, it's just disappeared. What the? Okay, let me run it locally. Instead. Okay. I got no idea. Like, the program is actually... The program itself is using, like, nothing, somehow. So I'm going to try going up to 16 by 16, which was really laggy before. It was running at, like, 10 FPS, something like that. So let's see if that happens again. Well, yeah, it's still pretty laggy. This optimization did not work. Yeah, it's weird that OBS's GPU usage goes up to 100% instead of the program itself. Maybe because it's being captured right now. Could be. Also, just by the way, it's using 60% of my GPU, OBS. Just sitting here. That's crazy. Well, I'm a little bit disappointed that didn't seem to have any effect. Although I haven't verified it yet, so I'm setting the ray origin. Actually, I should say equal to. That's the same thing. Ray direction times this number. Okay, and it didn't look like it had any errors, which was interesting. But there was no errors in the rendering. And then we do 64 steps, which is kind of crazy. I don't think we need to do that. But yeah, I didn't actually do the second part of the optimization, which was instead of checking everything in the scene, we just check a 3x3 basically around the point. So I guess we could just change this into a 3x3. Of course, it doesn't actually, it wouldn't actually be the first 3. It would be the 3 from the position of the of this, right? The 3x3 around this point here, so it'd be like this. So maybe I need to add that part to see any notable difference, or maybe I need to just profile it somehow. Let's see if RenderDoc can give me some more information about this. So let's have a look. All right, we'll look at this. All right, looking at this, I'm gonna press F12 and look at the frame data here. Now, is there like a timing thing? Timeline? That's this thing, right? Okay. Yeah. That's nice, but it doesn't actually tell me, you know, milliseconds or nanoseconds or anything. Maybe that information is somewhere in here. Just not sure if it's available. Statistics viewer. So this is for just this frame. What do we get? API calls 25. Textures, buffers, 32 megabytes grand total, GPU buffer plus texture load, okay. It's not really what I'm looking for. Performance counter view, okay. What is this? Capture counters, generic or NVIDIA? Okay, I guess I'll use generic. Load? Oh no, I need to load, I need to capture it? Okay. Well, you know what I could do? as a really simple test, I could just get the time of the frame, which I think I'm storing on the delta time here. Yeah, so I could just print the delta time, which is, yeah, you know, not great, but because it's going to be slowed down by printing to the console as well. But I guess we can get a relative difference. So this is with the optimization on. We're getting basically max FPS here, 0.008. I got 120 hertz monitor, so that seems about right. Okay, and then with the optimization off. So basically we just uncomment this. Getting the same. Okay, I think we need to add more, or it's not doing anything. That's also possible. I need a way to check. No, the buffer does exist, right? Yeah, it does. Yeah, I've already checked the numbers in there. Oh, did I compile it? I think I did. Okay. But I'm gonna increase this. So I'm gonna make it a little bit laggy. Sorry guys, if I don't know what it's like on the stream actually, I just know that it's probably not great. So we'll run this. That's not even, well, it's not bad for me. So we're just getting pretty solid 0.08. If I turn around, if I go outside, interesting. That's weird. I need to get a little bit slower on the frame rate. There we go. Alright, so now we're getting like 0.01. That's good. Something like that. Okay. That's great. So now I can actually see if it makes a difference. It doesn't seem to. Interesting. Huh. So if I look away, it runs at full frame rate, which is good. If I look towards, then yeah, 0.0102, 0.013 or 0.02-ish. So I turn this off again. Just gonna double check again. 0.013 and 5. Yeah, I think it's like slightly fast. Very slightly. Interesting. Well, that was only one half of it. So here's the other half. This is going to be a 3x3. The coordinates is going to be x plus actually I'll make it a vec3 hit position, something like that. Whoops. You know what I should do instead of this? Vec3 coords. Actually, it's not really coordinates. Whatever. plus hit pos divided by 16. I think that will work. Now if we use the map function here, we're calculating normals. That's going to be unfortunate. What if I just don't calculate normals right now? I think we need to. Alright. Okay, now the hit position is going to be basically the ray origin. If this works. It's not really, actually. It's going to be the ray origin plus this. Okay. So we got the p value. Yeah, I don't know why I actually did that. I should just set the p value. I don't need the hit coordinates. Oh no, the p value is the current position, isn't it? Let's see. No, it's the current position of the ray. Yeah, okay. So I don't need to do any of that stuff that I just did. I can just change this function. Well, that's what I already did, and it wasn't faster. Oh, yeah. Because I need to do this part. So we're going to actually scale it. It's going to be x plus p plus x. Okay, let's see if that works. So I'm just trying to get the correct voxels. I think that is incorrect. But let me look at the frame rate. Come on, where is it? Well, the frame rate's much better. It's just max, but that's kind of what I would have expected. But the thing is, I'm not getting the other voxels because I must have messed this up. Yeah, so this needs to be coords, I believe. No? What am I missing here? So we add the p value to the box. X, Y, Z. Okay, yeah. Whoops. Yeah, I guess p would stay the same, and then this would change. Wait, is this even gonna work? Whoops. I gotta think about this. So let me just comment this code out. So basically, if we pass in a position that we're looking from, but it's actually where we're evaluating from, which is increasing over time. So we've got 64 steps along this ray. Basically. Which means, okay, let's just test this first. So we've got 64 steps along this ray, and we've got a single cube in the scene. Then what should happen is, if I comment out this, if I move 64 units away, we shouldn't be able to see the cube here. So if I move far enough away, it should disappear. Let's go back further. Okay, it's gone. Get it partially into view. Yeah. So that must be about 64 units, which looks roughly right, I think. If that's 16, we're like 4 of those big blocks away. Yeah, I think that's correct. So, if that's the case, then what was the next step? I wish I could just check how fast this was in the shader somehow, but this should give us a significant saving because we don't have to traverse the whole space. However, if we move outside that chunk, the first chunk, then this is going to index into undefined, like memory that's not defined. So if we move over here, I don't know what's happening. It's like undefined behavior, I guess, probably. Because we don't have any SDF data in the chunks out here, for the chunks out here. So maybe this is zeros, maybe it's like random numbers and it's all getting messed up. No idea. Now, the next step is, let's just turn this off and let's say, actually no, we need this on. So we turn this on and let's say this is working and we're inside the first chunk. And actually I'm going to draw, can I draw an arbitrary rectangle? An arbitrary debug shape? I don't think I can. There's debug shapes. Where are they? Debug shape is F32. So I can't draw a random thing. Hang on a second. Where are all those? Oh, that's where the cubes are coming from, right? So if I say data, I'll just delete these. 0 is equal to debug shape as F32. So I want a cube and I want it to be yellow. But I kind of want to scale it. So right now we've got shape and color in the debug shader here. Where is it? Yeah, shape and color, but I would like scale maybe. So if I say options, maybe another 4 bits, so we can scale it by 0 to 16. Maybe that works well for our world. And then I guess we would say what? Scale equals, well, it's just converted into a float, I guess. And then I would need to multiply the position by the scale, but only for some of the vertices, and for the other ones I'd need to subtract them, I believe. It's a bit of a problem because we're only drawing 1 meter things right now. Okay, I'll figure this out later. That's fine, we can just do that. We can just draw a yellow cube at... How do we do it? Position? Yeah. I should just draw a yellow cube there. Yeah, that's fine. So, back to the SDF stuff. This should give us the position that has surrounding voxels that can be tested. And the idea is that the map function is going to test only those voxels. So we basically say we want to check in here, I guess. Same thing, int x equals, let's actually say -1. X is less than 1. Or s less than or equal to 1, and then plus x. So we'll do this. And the idea here is we're going to get the position. So p plus vec3 xyz, I suppose. This is actually the voxel position. Now we're going to need the texture coordinates. That's going to be the texture coordinates of each voxel. So it's going to be voxel position divided by 16. But we might want to seal the voxel position, I think. I'm not sure actually which way would be better. I'll just divide it by 16 for now. I think that should be okay. And then what? We say if texture, world texture chords dot r is greater than 0, then we know there's something. Actually, no, it's the opposite now. If it's what was the value in there now? Oh no, the texture's unchanged. We're using a different buffer. So if it's greater than 0, then there is something in there, and we want to draw a box there. I'm just going to use the min function this time. SD box, and it's going to be at the voxel position, but it's going to be our position minus, or the raised position minus the voxel position. 0.5. I think that will hopefully work. Okay, did I make a mistake? I made a mistake. What is it? Wait, what? If, unexpected if, expecting comma or, right, semicolon. We got, and another one there. SD box, no overloaded function found. Yeah, I'm missing, what am I missing here? Right, that is a problem. Alright, that definitely looks weird. Interesting. There's a lot of noise down there. Just, oh yeah, when we walk outside it doesn't work. That's good. That's good. That's what I expected. Okay. Of course it still doesn't work when we're inside though, which is a bit of a problem. But that's okay. Now, do I want to test from like... I always want to test from P. Okay, that should be fine. Ah, yes, this is... No, this is correct. P plus... Yeah, so we should be going in the directions from the point that we pass in. Is this working correctly though? I think yes, but maybe no. Is this the correct position that we need to check? I don't think so. I think we want to check relative to origin instead of world space. I think that's right. Alright, that's interesting. There's some stuff over there. It's a 3x3 shape of some kind. It's very grainy. Alright. That tells me that this is not correct either. So yeah, we're always supposed to subtract the position that we want from here. And so this would be a box at 1 by 1 by 1, but maybe we're stepping too far. Oh, hang on. What the? Okay, if I'm standing on this row, it works. That's interesting. And if I move out of here, it seems to be working. If I move in, what the? All right. Very strange. So the optimization that I'm trying to do is making the geometry look more solid. Hi Rudy, how you doing? So if I try something like what I was doing before, which was basically this, right? Except this was not correct. All right, we're back to blobbiness. Basically trying to optimize this rendering here. So see these blobby cubes? They are really expensive to render right now. So we're only drawing 3 by 3, but if I up this number, the stream is gonna lag. So if I make it like an 8 by 8, and there it is. Okay, so that is interesting. These coordinates are wrong. I'm going to go back. Do I have a previous version that I had when I first started? Yes. Pretty sure this version was working. Well, the blobs are a little bit weird, but yeah. Interesting. Is the entire cube getting rendered, or only the visible parts? Can a voxel work like this? I'm not exactly sure what you mean, but it kind of depends which cubes you're talking about. Are you talking about the white cubes or the blobby cubes? Alright, so let me just see, what's the difference between these two? Coordinates, x, y, z. That's all the same, that's the same, that's the same, that's the same, that's the same. So I think the difference is actually in this part down here. The blobby ones. Well, I'm rendering them using a technique called Raymarching, which allows you to do pretty interesting stuff like, let me see, there's a video that I had like this. So this is all rendered using Raymarching. There's no triangle rasterization here. So you can kind of have things that meld into each other and deform and stuff. Now the problem is getting the performance up. So I'm just working on that now. Trying to figure out how to do a simple optimization before I move on to something more complicated. But basically, rather than rendering a triangle of a cube or of a blob, what is happening is a ray is being fired for every single pixel on the screen. Well, actually, in our case, did you see there was that little box in the middle? I've limited the ray casting to that little box. So every single one of those pixels in the little box is having a ray cast fired out, and then checking basically every single voxel in the scene to see if it's hitting any of them. The parts that aren't in the little thing, they're just normal triangle-based cubes that I rendered last time. So I've got two rendering pipelines running right now. I just wanted to make sure I could get a chunk rendering using a 3D texture as the whether something's solid or not. So if we have a look here, there's a texture, here it is, 3D image. I'll zoom in for you. So you can see this 3D texture, where it's red, there is voxels, where it's black, there is no voxels. And it's got 16 slices and 16 by 16. So this is actually where the chunk data is coming from. I just wanted to make sure I could get that part working, so I used a simple triangle rendering technique first. And now that this is working, I want to see if I can get a more complicated rendering setup working. So I'm going to try something a little bit lame, which is to just subtract 0.5 from that number and see what happens here. Sorry, I just had to ban that person. These slices are insides of a voxel. What slices? Sorry. Oh, you mean the ones on the screen? Oh, no, right. On the... Yeah. These things. I was just showing you, right. Totally had a brain fart there. Yeah, that's right. Inside of a voxel chunk. So this is one big chunk here. You can see the shape. And that's the same shape here, but it's upside down. This kind of shape. Alright, so this is incorrect, isn't it? I believe so. Also, I should be able to see all of the voxels, not just these ones. The squishy voxels. Except this position needs to be offset by the hit position, which maybe means I do this. I don't know, is this gonna work? No, that doesn't make sense. I think maybe I do need both parameters in here. That gives me the same result. Interesting. Oh, of course, because this is the wrong loop, or rather, this needs to be, this is just the position 0, 1, and 2. It's kind of interesting that it shows up where it does though. Why is that? Oh, because I've added the P here maybe? No. Right. That does look... That's correctly conforming to the structure. Yeah, I feel like I'm missing something here in my understanding. So when we're evaluating the world, we pass in a position to the map function, which is going to be the position of the ray. And then if it hit, I mean, if the distance is greater than 100, or if we went too far, then we break. But if the hit is less than 0.01 away from the ray, then we got a hit, and then we can do all this stuff. It's fine. P equals RO plus ID times T. But I gotta remember that it's for every pixel. What if I set the T to be RO plus RD, no, just RD times this, cannot convert from float to, oh yeah. Okay, that looks correct. Alright. I think we might be onto something here. Now, the position of each voxel though has got to be different. Depending on the ray position, which means we've got to do something like this. P plus, oh, hang on a second. P divided by 16 plus these numbers, is that the problem? Well, that made everything, oh, interesting. That is not good. Let's do this. P plus X, Y, and Z. So that's going to be -1, -1, and -1. And then it's going to be less than 2. So we're going to get a 3 by 3 area around the point, right? Yes. Then we're going to get the texture coordinates, which equals coordinates divided by 16. Okay, and now this should be, I suppose that's correct now, I think. Missed the semicolon again. Damn it. What am I doing wrong? Okay. That's a very strange looking construction. Also, I don't understand why I can't get the other voxels. And yeah, I'm only comparing against the 3 by 3 that it could possibly hit. But I thought that that would work. I guess not. Maybe I need to composite it somehow. I don't know. But I'm out of time, so I'm gonna have to figure this out another time. I want to thank you guys for tuning in. I'm gonna go and make some lunch and then do work. So hopefully I can figure this out sometime soon and we'll have something interesting to show. Because right now we're just showing glitchy, blobby cubes, which is not really exciting. Alright, thank you very much and take care.